YouTube channel. In this video I am going to explain you about Lagrangian and Hamiltonian equation. So as we know, Lagrangian and Hamiltonian mechanics are important part of classical mechanics. So before going to start, if you are new to my channel, please subscribe my channel for upcoming videos. Let us start. So Lagrangian and Hamiltonian are the two different formulations of classical mechanics. So Lagrangian and Hamiltonian mechanics describe the motion of particles or system of particles. So Lagrangian and Hamiltonian, how we can differentiate? Lagrangian is the function of coordinate and their velocities, whereas Hamiltonian is the function of variable coordinate and momentum rather than velocity. So in general, as we know, Lagrangian and Hamiltonian usually we represent in terms of kinetic energy and potential energy. So Lagrangian is difference of T minus V, that is kinetic energy and potential energy, whereas Hamiltonian is sum of kinetic energy plus potential energy. We call it as total energy. Okay. So if we want to solve problems related to Lagrangian and Hamiltonian, you must remember these equations. Very important. These are the equations helpful to solve any problem given related to Lagrangian and Hamiltonian. So this is the equation related to Lagrangian. D by dt dou L by d theta dot is equal to dou L by dou theta. And Hamiltonian is given by this equation. Sometimes they used to convert Hamiltonian to Lagrangian and Lagrangian to Hamiltonian. So this formula is very helpful. And the coordinate and momentums, that is qi dot is equal to dou h by dou pi minus pi dot is equal to dou h by dou qi. Derivative of Hamiltonian. These equations are very helpful. So let us solve some problems here. So here in this question, if the Lagrangian of a particle moving in one dimension is given by L is equal to x dot square divided by 2x minus v of x, then Hamiltonian is, they have given here Lagrangian, you have to find out h. Okay. So here we can see 4 options also has been given. So let us try to solve here. First what you have to do, they have given Lagrangian, then first write the formula for Hamiltonian, that is function of coordinate and momentum, px x dot minus L. This is the general formula. Then you have to take the derivative of Lagrangian if you want to have the momentum p. Okay. So dou L by dou x dot is equal to momentum px. X dot, this if you modify, that will be x dot divided by x is equal to px. Nothing but x dot is what? Px into x. If you take the derivative of this L, dou L with respect to x dot, you will have x dot by x is equal to px. So then x dot you got in this Hamiltonian formula, you have to substitute here L and x dot. H is equal to px into px x minus L is what? X dot square divided by 2x minus v of x. So here it will become, if you multiply, this will be plus v of x. So Hamiltonian H is equal to p x square divided by x divided by 2 if you equate these two terms, and that is plus v of x. So this is the final answer, Hamiltonian. So we have converted Lagrangian into Hamiltonian. The correct option is here, option A. So the next equation here, they have given Hamiltonian and you have to find out the Euler-Lagrangian equation. Okay, the given Hamiltonian is x p square divided by 2m plus half kx in one dimensional system. M and k are what? Positive constants. Then you have to find out the Lagrangian. So the options, you can just see the options. Then first what you have to do, you have to write down the given Hamiltonian and the equation of motion for Hamiltonian, dou x by dou p is equal to what? X dot. That is equal to h, you have to substitute here. Take the derivative with respect to p, momentum. If you take the derivative, xp divided by m is equal to x dot. This term is going to be 0. With respect to p, we have to derive. So the momentum is what? P is equal to mx dot divided by x. Okay. So you can just write down the Hamiltonian equation here. As we know, this is the general formula. So we want L here. So they have given H. So L is equal to x dot p minus x, H. So substitute the value of H and p. You will get the Lagrangian. So x dot p minus xp square divided by 2m minus half kx. Just evaluate it. So the final answer after solving it, you will get mx dot square divided by 2x minus half kx. So here you got the Lagrangian. Then after getting Lagrangian, you have to find out Euler-Lagrange equation. So what is the equation here? D by dr dou L by dou x dot minus dou L by dou x equal to 0. Then if we take the derivative of L with respect to x dot inside the bracket, you can see. Then with respect to x dot and x, you have to derive the Lagrangian. Then you will get the Euler-Lagrangian equation here. So do dl by dx dot and then dl by dx. So this is the equation you get. If you modify it, take the LCM, you will get 2x mx double dot minus mx dot square plus kx square. So like that you have to convert given Hamiltonian into Lagrangian. So compulsory one question will be from Hamiltonian and Lagrangian. So please try to concentrate on this. So the answer here, correct option is which one? Option C. Okay. So the next question here, sometime they will ask to solve the Lagrangian and Hamiltonian. So Lagrangian of a particle of mass m moving in one dimension is given by, where b is what here? Positive constant. The coordinate of the particle at time t is given by. So you need to find out the coordinate, that is x as a function of t. So let us try to solve it. So the equation of motion for Lagrangian is what? General equation. First you should write down this equation. Then put the value of L in this Lagrangian equation. Derive with respect to x dot and x. So here half mx dot square is there, you have to derive with respect to x dot and minus bx with respect to x. So d by dt mx dot plus b is equal to 0. So m, if you take common, x dot d by dt, that will be x double dot, this term, plus b. So m x double dot is equal to what? Is equal to minus b. Then x double dot is what? Double differentiation. D square x by dt square is equal to minus b by m. Okay. Then dx by dt. If you take the derivative, then you will get here minus b by m into t plus c1 constant. Integration you have to do, and again if you do integration you will get the coordinate of the particle x as a function of t, that is minus b by m t square by 2 c1 into t plus c2. c1 and c2 are what? Constants. So answer here option A is correct. So like that you can solve any problems related to Hamiltonian and Lagrangian once you understand the formulas or equations related to Lagrangian and Hamiltonian. So I hope this video is helpful. If it is helpful, please like, share and subscribe my channel. Thank you for watching.